This is lesson 2 in the quantitative chemistry section. This is all about balancing equations. So the first thing you have to be able to do is to write word equations for chemical reactions. And you need to understand what reactants are, what products are, and what state symbols are. We'll run through that quickly. You need to be able to balance unbalanced symbol equations, and you need to be able to write balanced symbol equations from scratch. Okay, so this is the key skill to get right first, and then once you know your formulae, which you should do from your bonding section, you should be able to write them from word equations. So the first thing to make sure that you understand and you recap from Key Stage 3 is what is a word equation. So these are word equations. Okay, so we are using the proper names for chemicals with an arrow in between to show that these are the reactants. And what's happening is that they are turning into products. So it's just like a maths equation, okay, where you have A plus B going equals C plus D, except that in a maths equation, you have an equal sign. Here in chemistry, we use an arrow, okay, and what happens on one side has to go through to the other side. This links in back into our mass conservation. So in the same way that you've got the equivalent sign means that you've got the same thing on both sides. In this case, it's not quite the same thing, but you've got the same atoms on each side. Okay, they just get rearranged. So this is your word equation. When you write a word equation or a symbol equation, chemists use something called state symbols to explain whether something is a solid or a liquid or a gas at room temperature. Okay, because these equations are always at room temperature. Okay. So S for solid, L for liquid, G for gas. Now there's one more that you may have seen, which is AQ, and it comes from the word aqua. Okay, which means the word is aqueous. It means that something is a solution. So what do I mean by a solution? Something like salt in water is a solution. So you've taken the salt, which is a white solid, and you've dissolved it in water, and you can no longer see it, but you know it's still there because you can taste it. So the salt is a solution, and this is aqueous in water. So these examples we did in class. So magnesium plus oxygen, oops, you should know, goes to magnesium oxide. You probably did this earlier on in your chemistry career. It's the stuff that burns with a really bright white light. Okay, so metal plus oxygen gives an oxide. Sodium plus water. Okay, so this is the little, you use a very small piece of shiny white metal that is kept in oil, and you put it in the water, and it's very highly reactive. And so it reacts with the water to give you sodium hydroxide plus hydrogen, okay, and iron hydrochloric acid. Sorry, I'm running out of space, so I'm going to put it down here. Okay, it gives you iron chloride and hydrogen. Right, so those are some word equations. What you can do is you can put some state symbols in here. So magnesium is a solid, oxygen is a gas, and it's making magnesium oxide, which is a solid. Sodium is a solid, water is a liquid, sodium hydroxide is an aqueous solution, hydrogen is a gas, iron is a solid, hydrochloric acid, worth learning this one, is always an aqueous solution, just like sodium hydroxide. Give you iron chloride. Now this will be dissolved in the water that is also present, and hydrogen gas. So I'm going to show you my way to balance equations. So we're going to look at the burning magnesium and oxygen, and what we just learnt, that we have magnesium plus oxygen goes to magnesium hydroxide. Right, so if we want to write this as a symbol equation and to write a balanced symbol equation, we need to write the formulae first up. So we're going to write the formula for magnesium, which is Mg. I'm going to represent this by a little green ball here, plus oxygen. Now the formula for oxygen is O2. It's worth learning that one, but if you think back to your section on covalent bonding, it's O2 because each oxygen has 6 outer electrons. It wants 8 to be stable, so it has to share 2 with another oxygen atom. Okay, so that's why it's O2. And we're going to make some magnesium oxide, which is MgO. Or OMG, as it seems to be put in lots of jokes these days. Right, so MgO I'm going to represent as a green ball attached to a red ball, okay, because I've got one magnesium and one oxygen. Right, so mass conservation. Mass conservation means that we've got the same amount of starting material as we do have products, okay, and that's because I cannot make atoms disappear or appear for that matter. Atoms have to go somewhere. So this have to have the same amount of atoms on this side of the reaction as reactants as there are on this side products. So let's count them up. So we've got one magnesium on this side, one magnesium on that side. That all looks fine and dandy. This one looks to be a bit of a problem. You've got 2 oxygens on this side and only 1 on this side. So we've got a problem here. Now, we are not allowed to just add another oxygen. I can't just stick another little red ball on there. Okay, because the only thing I can make on this side of the equation, the only product I'm allowed to make is magnesium oxide. So the only thing I can add is another unit of magnesium oxide. Okay, because I can't just start putting random other things in here. The only product being made is magnesium oxide. So let's have a look now at the oxygens. I've got 2 oxygens on this side, 2 oxygens on this side. Fantastic. That now balances up. But I only have 1 magnesium. Okay. Now I am allowed to add another magnesium because I'm not changing the compounds that I have. I'm not adding a new compound, but I'm adding 2 magnesiums now. So now if we look carefully, we've got 2 green balls on this side, 2 on this side, 2 red balls, 2 red balls. So this equation is now balanced. Now if we want to translate this back into chemical speak, this means we've got 2 magnesiums plus an oxygen going to 2 magnesium oxides. Simple. So I'm going to go through another example here. Okay, so we're going to have, this time it's got sodium and water giving sodium hydroxide and hydrogen. So our sodium, formula for sodium is Na. Okay, formula for water is H2O. Okay, going to sodium hydroxide, which is NaOH, and hydrogen, H2. Okay, so we're going to draw our little circles again. So we're going to have 1 sodium, we're going to have an H2O, you'll understand later on in chemistry why I draw it like that, why I don't draw it in a line. It's force of habit. And there's an NaOH and an H2. Right. So the first thing we can see is that if we add up the little balls on the reactant side and the product side, the main issue we've got here is that we've got too many hydrogens. Okay, so we've got too many hydrogens on this side. We've got 3 on this side and only 2 on this side. So we've got a bit of an issue. We're going to have to put together, and we're going to have to put more hydrogens on this side of the equation. So the only thing we can do, if we want to put more hydrogens on this side of the equation, the only substance that we can add is another one of the H2Os. We can't just add a random hydrogen atom. That's not allowed. Okay, but we can add another water. Right, So now we've got 4 hydrogens on this side, 3 on that, 4 hydrogens on this side, 3 on that side. Got 2 oxygens on this side, 1 on that side. Oh gosh, this looks like we've made an even more of an error. Okay, but keep the faith. Let's have a look at the oxygens now. Okay, so we've got 2 oxygens on this side, but only 1 on this side. Right, well let's try adding another one of the substance with the oxygen in it. Right, this is beginning to look a little bit better now. Because look, we've got 2 oxygens on this side, 2 oxygens on this side. Got 1, 2, 3, 4 hydrogens on this side. Got 1, 2, 3, 4 hydrogens on this side. So we're balanced in terms of oxygens and hydrogens. The only thing we're not balanced on is sodiums. But sodium's easy, we can add an extra one of those. Now it is balanced. We've got the same amount, little balls on this side as we've got on this side. So now we translate it back into chemistry. So the balanced equation is 2Na plus 2H2O going to 2NaOH plus H2. If you want to be super good, you should write your state symbols on there. Solid, liquid, AQ, and a gas. Simple.